Hi there, welcome. In today's lesson, I'm going to explain the chapter A Square and a Cube, which is 8th Standard, CBSE, Part 1, Ganita Prakash, the first chapter. Alright, I have made a couple of videos for this chapter previously, but in that, what I was basically doing was trying to make it in smaller parts, and I have decided not to do that and instead make one probably longer video, but it will be covering the entire chapter in one go. All right. So a square and a cube. The very first question that you should think of is that what is a square and what is a cube? All right. Now, when we think about a square, most probably what you will be thinking about is a geometrical shape, which is this, right? So it's a four-sided figure with 90 degrees and each side is equal, and this is a square, right? And this is a 2D figure, correct? And the cube is a 3D figure where once again all sides are equal, but now this is a 3D figure, right? This is a square and this is a cube. Okay, these are the two things, and this is as per geometry. The chapter that we're going to study here today, this is not geometry, this is arithmetic. Okay, and now in this chapter, the words square and cube have a whole different meaning. They are similar in some ways to this, or you can just say they are connected to this, but they're not this exactly. So we'll begin with square and then we will move on to cube. All right, so let's start with square. Now there are a lot of different terms. You have square of something. So let's say square of the number n. Then there's the word square root. Then there's the term square number. These are very similar words. So let's just see one by one what these mean. Let's say I have some number, whatever this number might be. Okay. If I multiply this number with itself, so let's say I have the number 5 and I multiply it by itself. The same number is multiplied by itself. And you get some answer. What is 5 into 5? 25, right? Now, 25 is the square of 5. So that's this point. Okay? So 25 is the square of 5, which means that I multiplied 5 by itself and I got 25. 25 is the square. Okay? What is square root? Square root is just basically the number which was multiplied by itself. That is the square root. So 5 is the square root of 25, which means the same thing, that when I take the square root of 25, when I find the square root of 25, it's going to be 5. Okay? And what is a square number? In this equation, this is simply a square number. 25 is a square number. Okay? And as I said that you can connect it with this. So basically, over here also, if you multiply A into A, what will you get? You'll get the area, right? So the area of this square and this square number, they will be equal. So that's just the connection, okay? Similarly, when you'll take the cube, it would actually be the volume, because the cube is A into A into A 3 times. So then that's going to be the volume. But right now, it's just the area of this square. So once again, if you have any number that can be expressed as some number multiplied by itself, then this is called a square number. Okay, and it is the square of these numbers, and this is the square root. So if I write 2 into 2 and I get 4, 4 is a square number and 2 is its root. Now there's another way of actually writing this. You will write 2 and then you'll write the power 2. This means that 2 is multiplied by itself 2 times. Okay, so 2 square, this is how you say 2 square, that's equal to 4. Let's say it is 9 into 9. It will again be 9 square, which means 9 is multiplied by itself 2 times. So that is 81. 81 is a square number and the root of 81 is 9. Okay. Now, can you take a square of some number which is like not a natural number? Of course you can. If I say 2.5 into 2.5, the answer will be 6.25. And this is also a square of 2.5, right? But now this is not a natural number. Now 2.5 is not a natural number. And so this number is not a perfect square. So a perfect square, so we had these 4 terms over here. There is one more term which is a perfect square. So what is a perfect square? A perfect square is a number which is the square of a natural number. So whatever this n is, okay, if it's a natural number, then the answer, the square will be a perfect square. Okay, because 6.25, the square root of 6.25 is 2.5, so it is not a perfect square. 6 is also not a perfect square. Why? Because you cannot say that 6 is a number which can be expressed by some number multiplied by itself, right? So 6 can be written as 2 into 3. And these are both different numbers, right? So 6 is not a square, it's not a perfect square, it's not a square number. Alright? Let's see a few of the numbers, what they are, right? So if you have 1 square, that means 1 into 1. So that's 1. Similarly, 2 square is 4. 3 square is 9. 4 square is 16. Okay, and I'll just finish all of these and I'll continue after that. So this is I've just made a table of all the squares of numbers from 1 to 20. So these are all square numbers: 1, 4, 9, 16, 25, 36, 49, 64, 81 and 100. These are all square numbers, right? So now what we need to do is we need to understand what are the properties of square numbers and are there any patterns. Why is this needed? Because when you see a number, right, if you are asked whether it's a square number, if it's not a square number, if it is, then what are the square roots of it, right? All of that, when you reach that point, you need to know how to, figure out whether a number is a square number or not. Let's say you've given like 5 numbers and asked what are the square roots. Sometimes you can just look at a number and tell that this is not a square number, right? So how can you do that? How can you tell just from looking at a number whether it's a square number or not? All of that is done using properties. Okay, so we will go one by one for the properties. But before that, I want to explain something, that why these properties will be, the way they are. Why will there be patterns? Let's say I am multiplying two numbers. Okay, I am multiplying 5 and 3. Okay, so when I'm multiplying 5 and 3, the answer is 15, correct? Now, for this number, the units digit is 5, right? Now, let's say I am multiplying 15 and 3. Okay, what will the answer then be? It will be 45. And the units digit will again be 5. Why this 5? Because these two didn't change, correct? So the units digit of these didn't change, and that is why the unit digit of the answer didn't change. The tens place changed, that's true, but the last digit did not change, right? Similarly, if I make it 5 into 13, so this will be 65. And once again, the unit digit will not change, correct? This is just a simple property of multiplication, correct? The units digit of the two numbers that are multiplied, they will decide the units digit of the answer. Now, in the same way, if this is a square number, so if it's 5 into 5, then it will be 25, right? If it is 6 into 6, it will be 36. Similarly, if it's 7 into 7, this will be 49. This means that if your number, no matter how long it is, if the ending digit is 5, the final answer, which is the square, that will also have the ending digit as 5. And if your number, the square root, ends with 6, this will end in 6. If it ends in 7, it will end in the square will end in 9, right? And the same thing you can see here also, right? 2 square is 4 and 12 square is 144. Both of them end with 4, right? 3 square is 9. 13 square ends with 9. 5 square ends with 5. 15 square ends with 5. That doesn't change. The pattern will be same. Which means even, let's say, if I have 8 square is 64, right? And I have 18 square, that is 324. If I have a number that ends in 8 and I take a square of this number, which means this number is multiplied by itself. I'm not going to do that. But if that is the case, whatever the answer will be, that number will end in 4. This last digit will not change. Is it making sense? Now this is what will tell us what the first property is for a square number that we need to look at. That whatever digits for the units place, for the last digit, are there in these first 10, they are not going to change. Okay? So this means that you can have numbers, if you have a perfect number, perfect square, it could end with 0, it could end with 1, but it cannot end in 2 and it cannot end in 3 because none of these end in 2 and 3. Right? It can end with 5, with 6, but it cannot end in 7 or 8. And it can end with 9. Right? Because that is the pattern that we've seen here. Nothing multiplied by itself can give you a number which ends in 2, 3, 7 or 8. It is not possible, right? So, that is the first property. A perfect square cannot end with 2, 3, 7 and 8. It cannot end with 2, 3, 7, 8. Does this mean that, if you have these numbers, the other numbers, it will definitely be a perfect square? So basically a perfect square can end with 0, 1, 4, 5, 6 and 9, right? But does it mean that if it is ending with this, it will definitely be a perfect square? No, that's not the case. We've already seen that number 6 is not a perfect square, right? Similarly, 26 is also not a perfect square. Perfect square is which one? It is 36, right? So similarly, even 46 is not a perfect square. So they can end with this, but they definitely cannot end with these 4. So if you have a number which ends with these 2, 3, 7, 8, you can directly say that it is not a perfect square. If it ends with these, then you'll be like, okay, now I have to think. Now I have to check other properties. Now I have to see if it is possible for some other way to figure out whether it's a perfect square or not. But if it is ending with this, it's directly not a perfect square. So now next thing is, we just saw that it has patterns. If the square root has the number 4, the square number will always end with 6. So what does this mean? It means that if the perfect square number ends with 1, the roots or the root will end in either 1 or 9, right? Let me remove this book, right? It will end with either 1 or 9. So if let's say you have a square number here and you have the roots here, okay, so if the square number ends with 1, the root will end with either 1 or 9. If this ends with 4, the root will be ending with either 2 or it will end with 8. If this ends with 5, the root will end with 5. If it ends with 6, the root will end with either 4 or 6. If it ends with 9, then it will end with either 3, the roots, or 7. And if it ends with 0, the root will be ending with 0. And this you can verify with the basic 1 to 10 ka square. If you just look at that, you won't have to remember this, right? So that is the next property. If you have some square number and you know which number it ends with, you know that the root will end with which number. Okay. Next property. So this is second property. Now next property is about the 0. Now let's say I have the number 10 and I want to take its square, which means I have to do 10 into 10, right? So 10 into 10, the answer will be 100, which means there will be 2 zeros. There was 1 0 over here and there are 2 zeros here. Similarly, if I have to do 100 into 100, then that means this will be 10,000. And again, there will be twice the number of zeros. But this is not just related to 100, right? If let's say I have 20. And 20 square is 20 into 20. This answer will be 400. I will multiply, I will take the square of 2 and I'll write it here. And this was 1 0, I'll make it 2 zeros. Similarly, if this is 40 square, which is 40 into 40, it will be 1600. The 1 0 will convert into 2 and your 4, you will have the square over here. Which means that anytime you have a single 0 in your root, the square will have double that, 2 zeros. Or if you have 2 zeros, there will be 4 zeros in the square. So however zeros you have here, your square number will have the double amount of that, right? So if your square root has n zeros at the end, its square will end with 2n zeros, okay? Which then means that if you have a perfect square, it has to have a number of zeros which is even. If you have 1000 and someone asks, is this a perfect square? This number has 3 zeros. 3 is an odd number, which means that 1000 cannot be a perfect square. So, a perfect square cannot have odd number of zeros at the end, right? And once again, it does not mean that if it does have even numbers, it is definitely a square number, right? So you know that 400 is a square number. It's the square of 20. But if I say 500, this has 2 zeros. But 500 is not a perfect square, right? You cannot find a number which when you multiply by itself, you get 500. Okay? So, once again, if you have a list of numbers and you have to figure out whether they are perfect or not, perfect square or not, if they have an odd number of zeros like this, you can say that it is not a perfect square. But if it has an even number of zeros, you still have to, look at the other properties again. The next property is about the parity. What is parity? Parity just basically means odd and even. So this is very simple. If you have an odd number and you take the square of it, the answer, the square number will also be an odd number. And similarly, if you have an even number and you take a square of it, that it's also going to be even number. Okay. So let's say 2 into 2 is 4. That's both of them are even. 3 into 3 is 9. Both of them are odd. 12 into 12 is 144. Both of them are even, right? So no matter what the number is, whatever the parity is, whether it's odd or even after, like when you multiply it by itself, when you take the square, the parity will not change. Okay? So that's the next property. Now before we move on, let's look at a few questions from this Figure It Out, which is on page number 10, right? And this will help you to understand what we are trying to learn over here. Okay? So the first question, which of the following numbers are not perfect squares? Okay, which of the following numbers are not perfect squares? There are 4 numbers over here. 2032, 2048, 1027 and 1089, and we have to tell which of them are not perfect squares. Now when we go back and we look at our properties, right? One of the first properties that we saw was that a perfect square, this one, a perfect square cannot end with 2, 3, 7, 8, right? Now, let's again look at this. The first number is 2032. This number ends with 2, which means that it is not a perfect square, right? Because a perfect square cannot end in 2. Similarly, 2048, this also ends with 8, and we know that it cannot end with 8. Then we have 1027. We know that 7 is also not possible. So 1027 is also not possible. Correct? Then last we have 1089. Now this number 1089, it is possible that this is a perfect square. Correct? Now we need to figure out whether this is a perfect square or not. How will we do that? we will learn that, right? We will learn how to do that in some time. For now, we just know that the first three are definitely not perfect squares. Fourth one, we have to still figure out. Okay? Next one. Which among the following have the last digit 4? So if I take a square of these numbers, 64 square, 108 square, 292 square and 36 square, the answers, which one of them will end with 4? We have the last digit 4. This is again, we know, if it ends with 4, if the square root ends with 4, the answer will end in 6. Correct? So 64 square will have the last digit 6. So that's not the answer. 108. Now 8 square is 64. So 108 square will end in 4. Correct? Then we have 292. 2 into 2 is again 4. So 292 square will end in 4. And 6 square is 36. So 36 square will also end with 6. So which one of them have the last digit 4? That is 108 and 292. The square of these numbers will end in 4. Okay? So these two questions are based on what we have studied so far. Let's move on to the next thing. Now let's look at a few patterns. I will write the square numbers in a line. Okay? So I have 1 square, 2 square, 3 square, 4 square, 5 square. Let's write one more, 6 square. And so on. Right? What is this? 1 square is 1, 2 square is 4, 3 into 3 is 9, 4 into 4 is 16, 25 and 36. These are the square numbers and these are the roots. Now, is there any pattern between them? Is there a pattern that's happening over here? Let's see. If I subtract 1 from 4, I will get 3. If I subtract 4 from 9, I will get 5. 16 minus 9 is 7. 25 minus 16 is 9. And 36 minus 25 is 11. And in fact, if you keep going over here, right, if you keep going 7 square, 8 square, 9 square, the difference will continue like this, right? They're going to be odd numbers. 1, 3, 5, 7, 9, 11, 13 and so on. Okay? So this is the pattern. If I want to write the square of 1, I will write the first odd number. If I want the square of 2, I will write the sum of the first two odd numbers. 1 plus 3 equals to 4. Okay? If I want for 3 square, that will be the sum of first 3 odd numbers. 1 plus 3 plus 5. And that is 9. Similarly, for 4, it will be 1 plus 3 plus 5 plus 7 equals to 16. So, for every number, if I want to find the square, I will have to add that many odd numbers in sequence. It also means one more thing. Now, if I want to find 4 square, right? If I want to find 4 square, I have to add 1, 3, 5 and 7. I already know that 1 plus 3 plus 5 is 9, which is 3 square, right? So I can also write that 4 square is equal to 3 square plus the fourth odd number, right? So 4 square is, this is 3 square, right? And this is the fourth odd number. let's say if I have to write the number 80 square, this will be 79 square plus 80th odd number, right? Or let's say if I want to do 91 square, it will be 90 square plus 91st odd number. Now this is easy, right? I know 90th square. How do I know 90 square? Because I know that if I want to calculate this, I can do 9 into 9. That will be 81. And then for 1 0, I'll write 2 zeros. Right? So 90 square is 81 square. And the 91st odd number, if I can find what the 91st odd number is, I can easily find this. I can add them. Right? So now comes the question of how to find this. This is very, again, easy. First odd number is 1. Second odd number, second number is 4. Third odd number is, 3 and 5 and so on, right? So this has a formula. And the formula is very simple. It is 2n minus 1. Right? So if I have nth odd number, that is equal to 2n minus 1. Let's try it. Let's try for 4. Fourth odd number will be 4 into 2 minus 1. So that's 4 to 8 minus 1. And that is 7, which is the right answer, right? So once again, if I want to check what is 91 square, right? And I said that it's 90 square plus the 91st odd number, right? Which is 8100 plus, now we know this is 2n minus 1. Correct? So this becomes 8100 plus minus 1. So this becomes 8100 plus 181, which becomes 8281. Right? So this is one pattern. What is the pattern? That if you subtract subsequent perfect squares, the difference will always be an odd number, and in sequence they are going to be odd numbers, right? And if you have any number and you need the square of that number, you will have that many odd numbers, you have to add them and you get the answer for the square number. Okay? Next thing is triangle numbers. We have a pattern for triangle numbers. So, what are triangle numbers? Triangle numbers, you start with 1, okay, and you keep adding one more, right? So, let's say this is 1. In this, I will add 2, right? This was 1, I will add 2. So then this becomes 3. Then to this, I will add 3. Here I added 2, now I will add 3. Right? So this becomes 6. Then I will add 4. So now this becomes 10. Right? So this way I will do, so 1 plus 1 plus 2 is 3. Then 2 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. And 15 plus 6 is 21. So these numbers are known as triangle numbers. So what is the pattern over here? If I have triangle numbers, so let's write these triangle numbers 1, 3, 6, 10, 15 and 21, right? These triangle numbers are there. If I add 2 of them, right? So here if I add these two, you will have 4. This will be 9 This will be 16, 25, and this will be 36, right? Which means now you have 2 square, 3 square, 4 square, 5 square, 6 square, and so on, right? So the first two triangle numbers, the sum of first two triangle numbers is equal to 2 square. Then second and third, their addition will be 3 square. Third and fourth, their addition will be 4 square. Fourth and fifth, the addition will be 5 square. Fifth and sixth, 6 square, right? So what does this mean? If you have n minus 1, okay, 1th plus nth triangle numbers, right? If you add them, your answer will be n square. Okay, so if this is 5th triangle number and then this is 4th triangle number, the addition will be 5 square. Alright, we have one more pattern. Now the next pattern is how many numbers between two consecutive perfect squares. Okay, now in this what we had done, 4 minus 1, so this was 3, right? This included 4, right? So if on a number line, let's say I write 0, 1, 2, 3, 4. So the perfect squares, what are the perfect squares over here? We have 1, 4 and 9, right? So how many digits are there between 1 and 4? 2. 4 and 9? 4, right? And similarly, when you go ahead, between 9 and 16, you will have 6. Okay? Simple. You have to do 4 minus 1 and then you have to subtract 1 more, right? So it will be, because 4 minus 1 is 3. But you have to remove 4 also. So then it will be 2. So this is simple. 2 n numbers lie between n square and n plus 1 whole square, right? 2 n numbers lie between n square and n plus 1 whole square. Now let's again go back to the figure it out and it will make sense. The third question now is, given 125 square is this much, what is the value of 126, right? So you know that 125, so this is again the third question now. 125 square, they are telling you that it is 15625. Okay, and you need to tell them what is 126 square. And this is the exact thing that we've studied, right? That 126 square will be 125 square plus 126th odd number. What is 125 square? That is this, they've already given us 15625. And what is 126th odd number? It will be 2n minus 1, right? So 2 into 126 minus 1, which is then 2 into 126 is 252 minus 1 is 251. And then this becomes 15876. And this is 126 square, right? So you have 125 square. You just need to add the 126th odd number and your addition, the answer of the addition will be 126 square. Okay? If you have a number, let's say 5. And if I take the square of this number, which means 5 into 5, you will get 25. What if I have the number minus 5? So minus 5 into minus 5 is also equal to 25. correct? The negative sign is 2 times. So what will happen? This will become again plus 25, right? So now this again tells us two things. Okay. First of all, a negative number cannot be a perfect square. Because even if you have a negative square root, right, the square number will still be a positive number. But it also means one more thing, that when you have a number and you take the root of it, this symbol means that you're taking the root of it. So the root of 25 can be both plus or minus 5. Right? So if you want to write, let's say, the root of 9, it will be plus minus 3. It could be 3, it could be minus 3. Right? Here in this chapter, we are not going to look at the negative numbers, but you should know that that is the case. Okay? Now we move on to how to actually find out the square root. Okay? So what are the ways that we have looked at so far? The very first thing that we tried was that we listed out everything. Right? This is the first thing that we had tried. We wrote down everything till 20. How did we do this? We multiplied this, right? 17 into 17, 18 into 18, 19 into 9, 20 into 20. So you can do this, right? You can just keep doing this. You can take out the square root of 21, 22, 23, 24. And you keep doing that till you reach whatever number your answer is, right? So that is the first way of doing it. First way is you list out all the square numbers. So let's say if the question is 484, okay? Is it a perfect square? So the first option is to list them, right? You've already seen that 1 to 20, you know it ends with 400. So you know that it's not less than 20. It has to be more than 20. Alright, so let me try. I'll do 21 square. So I will do 21 into 21. I will multiply these. And then I will find out that this is 441. So then this is not the answer. Then I will do 22 square. So I will do 22 into 22. And then, oh wait, it is 484. That is the answer. So root of 484 is equal to 22. This is all good. This is well and good. But what if it's a very big number? How many times you will, multiply numbers and try to find the square root? This is not possible, right? What if it's a 6-digit number? What if it's a 10-digit number? Right? This is not feasible. It's not practical. Then second method. Second method is the sum of the odd numbers. Right? The sum of odd numbers. We know that whichever number you have, that many odd numbers, if you add, you can do it. Okay, fine. Let's say, what if I tell you I want the 47 square? Okay. What will you do? You will write 47 odd numbers. 1 plus 3 plus 5 plus 7. You will do that and you will count 47 odd numbers and then you will add them and then you'll have an answer. Is that possible? Is that feasible? It's okay for small numbers, but it's not possible, right? It is okay for places where let's say like this one, in which they gave you that 125 square is this one, right? So this is also not the best way to do it. You can do it this way. Obviously, you can do it this way, but it is not the best way to go about it. Now, then the actual way that you need to use, or the best way, is the prime factorization. This is how you will actually find the square root of a number. We know that, let's say, a square number. What is a square number? A square number is when you can write something multiplied by itself. Right? So 4 is equal to 2 into 2 and then 4 becomes a square number. Similarly, if you have, let's say 144, right? So that's 12 into 12. And you get 144. So that's a square number. So if I give you 144, how will you find out this? This is where prime factorization comes in. Okay? You will basically take 144 and you will find the factors of 144. What are the factors of 144? This is how you do prime factorization, correct? Which means 144 is equal to 2 into 2 into 2 into 2 into 3 into 3. Now when you need to take the root of 144, what will you do is, you will make it into pairs and you will take one number from each pair. So this becomes 2, 2 and 3. So this becomes 2 into 2 into 3, which is now 12. Why is this true? Because 144 is now, 144 is 2 into 4 and 3 into 2, or it is equal to 2 square and 3 square. So if I want to take the root of this, right, I will take 1 from this, 1 from this and 1 from this, and then that becomes the root. Okay, let's say another equation, another question. Let's say we have the number 2025 and you need to find out the square root of this. Okay, we will again do prime factorization. Okay, this is not divisible by 2, so we move on to 3. This is how you do prime factorization, right? So now again you have 2025 is equal to 3 into 3 into 3 into 3 into 5 into 5, right? And again, once again you will make pairs and you will take one from each pair. So you will have root of 2025 is equal to 3 into 3 into 5, which then becomes 45. Okay, right? So this is how you'll actually find the square root of a number, which now then means that when we were doing figure out, if you remember the question, first question, we can go back to this one now, right? 1089. We can now check if it is a square number or not. If it has pairs, then it is a square number. If it turns out that that pairs can't be there, like pairs can't be made, then it's not a square number. So again, once again, this is the first one for figure out, 1089. Okay. So again, we will start with 3. Right? So 1089 is 3 into 3 and 11 into 11. And again, you can make pairs, which means the root will be 3 into 11, which means 33. Right? If you had to find this with the other two ways, right, you would have to either list down till 33 or you would have to add till 33 odd numbers. But here in this way, you can easily do this. Okay. Now, what happens if it doesn't have that pair, right? So let's try this one also, 2048, right? Let's try 2048. What happens? We've already seen that 2048 is not a perfect square, right? Because it ends with 8. But let's say we try it anyway. I make the prime factorization of 2048. Okay, that's the prime factorization of this, right? And if I make pairs, this is a pair, 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 and this is left out. Because this is left out, that is why this is not a square number. Understood? So if you cannot form the pairs, then it's not a perfect square. Okay? Now, we have fourth question. Fourth question is length of a side of a square whose area is 441. Now, as such, we already know that 441 is 21 square, right? We had seen it. Over here we saw. But again, once again, let's try it with prime factorization. So you have 441. We will again try it with prime factorization. So we will go with 3. Right? Which means 441 is equal to 3 into 3 into 7 into 7. And if I make pairs, 441 square root will be 3 into 7, which is 21. Okay. So the side of the square whose area is 441 is 21. Okay. So we have the next thing. The next question is find the smallest square number that is divisible by each of these following numbers 4, 9 and 10. Alright. So we need to find the smallest square number that is divisible by all of them. Right? Which means, see, whenever we need to find the smallest number that is divisible by 3 numbers, we will find the lowest common multiple, right? But now we also need a square number, which means that that number should also be a square number, which means it should also have pairs. So let's do this, right? We will start with the LCM. We will do the LCM of 4, 9 and 10. Okay. So I will just do the quick LCM of these. Right? So what is the LCM, the lowest common multiple? LCM is 2 into 2 into 3 into 3 and into 5. If I have this LCM, 180. 180, these are the factors of 180. If I make pairs, I can make these two pairs, but I can't make a pair of this, right? Which means that 180 is not a perfect square. To make 180 a perfect square, I need to make this into a pair, right? So, if I do 180 into 5, right? The factors for this will be 2 into 2 into 3 into 3 into 5 into 5, correct? And then I can make pairs, and then the root will be it will have a root, right? Which means 180 into 5 or 900 is a square number. Okay. So what is the smallest square number that is divisible by 4, 9 and 10? That answer is 900, right? Why? Because the LCM is 180 and that is not a perfect square, and to make it a perfect square, I need to make sure that each factor has a pair, right? So 5 did not have a pair, so I just multiplied it by 5 and I got 900. Okay. Next is 6th. Here the question is find the smallest number by which 9408 must be multiplied so that the product is a perfect square, and then find the square root of that product. This is exactly the same thing that we did here for 180, right? Whatever we did over here for 180, we are going to do the same thing. So we have 9408. 9408. So the first thing I will do is find its factors. So let's say this is 9408 and we need to find the factors. So 2 times okay. So this is the prime factorization of this, right? Again, let's see what pairs are there. We have this as a pair, this is a pair, and this is a pair, and this is a pair, right? So 9408 is equal to 1, 2, 3, 4, 5, 6 times 2 is there, right? So there are pairs into 3, into 7, into 7. So this is also a pair. So if I want to multiply this by something so that it becomes a perfect square, I will have to make this also as a pair. So that will be then 9408 into 3 is a square number. So this will then become 28224. And what is the square root of this? 2. You will take one number from each pair. So 2 into 2 into 2 into 3, because now you've multiplied by 3, into 7, which then it comes out to be 168. Okay. Next, number 7. How many numbers lie between the squares of the following numbers? 16 and 17, 99 and 100. This is again something that we have studied where, this one, right? This is something we did. So 2 n numbers lie between n square and n plus 1 whole square. So we have 16 and 17, right? If we want to take 16 square and 17 square, and I need to tell, and you need to know how many numbers lie in between them. So this is n square and this is n plus 1 square, right? And how many numbers will be lying in between them? 2n. So we will have 32 numbers, right? 32 numbers will be between 16 and 17 square. Similarly, if you have 99 square and 100 square, which is the next question over here, 99 and 100, that will be 99 into 2, which is 198 numbers, right? So 198 numbers lie between 99 square and 100 square. Now, this is a pattern question. Before we reach here, before we do this, I want to cover another important thing, which is the last thing that is left in our chapter, which is approximation, right? What is approximation? Approximation is that, let's say you have a number and you want to figure out what is the approximate square root of it, right? You don't want to do like massive calculations. You don't want to do prime factorization. You just need to figure out whether it's close by or not, right? So how are you going to do that? We'll take two examples, one where the number is in fact a square number and one where it is not. And this is going to be the same example which is there in the textbook. First of all, you have, let's say, 1936. Okay, you have this number and you need to figure out whether it's a square number or not. So now let's list down what numbers we actually know that are around this. Okay, so I know that let's see the numbers that we can easily do. Okay, we know that 10 square is 100, right? We know 20 square is 400. It's still far away, right? 30 square is 900. 40 square is 1600. Okay, now we are getting close. And 50 square is 2500. We are above it, right? Now then that means that we know that this 936 will be somewhere between these two, because 1600 is smaller than it and 2500 is more. So whatever the square root of this, it will have to be more than 40 and less than 50. Another number that we can check is what is 45 square. Okay, for 45 square, I will give you one very nice trick, okay, for these numbers which end in 5. Okay, what you're going to do is, if you want to take 45 square, for 5, you will write 25 directly. And you will take 4 and you will multiply it by the next number. So 4 into 5. So that's 20. And this is the square. Similarly, let's say if you want to do 35. For 5 you will write 25. And you will do 3 into 4, which is 12. Okay. This works all the time. So you have 25. If you have 6, then it is 6 sevens are 42. Okay. If it's a bigger number, then yes, if it's 16, 165, let's say it is, then you'll have to multiply 16 by 17. So at that point, then it might not be a quick trick. But here, this is going to help us, right? Because I know that 45 square is 2025, which is, once again, it is bigger than this, right? 50 square was 2500 and 45 square is 20. So now I know that this is 40, 1936 and 45, which means that the root of 1936 has to be between 40 and 45. It can't be 40 because 40 is too small. It can't be 45 because it is too big, right? So it's either 41, 42, 43 or 44. Now, if this is 6, if this is ending with 6, I know that the root will have to end with either 4 or 6, right? So if this unit's digit is 6, the root will have to end in either 4 or 6, which means the root can be either 44 or 46. Now it can't be 46 because 46 is already larger than this. Correct? So now what I will do, I will just try and see what is 44 into 44. And when you do this, you find out that it is actually 1936. Right? In this question, when they had given this in the book, they had said already that 1936 is a perfect square number. Okay. So, by approximation, we figured out that how it is, right? It is more than 40 square, but it is less than 50 square, but it is also less than 45 square. And it ends in 6, which means it has to end in either 4 or 6, and 6 is more, 46 is more. So, now it is 44. Got it? What if we know that it is not a perfect square, but we still need to find the approximate answer, the closest answer. So here, the example, again I'm going to use the example which is there in the book. Okay. So the question in the book is 250. You have 250. I need to know what is the approximate or the closest to the square root of this. Okay. Once again, we will do the same thing. Okay. We know again that 10 square is 100, which is less than 250, right? 20 square is 400, and this is more than this. Okay. So we now know that there is 10 square, then there is 250, and there is 20 square, which means that it has to be somewhere between it. So now, because first of all, I'll explain that because we know that this is not a perfect square, this step which we had done, this step will not be possible, right? Because we know that it's not going to happen here. So we need to just keep going closer to this. So we did 10 and we did 20. Just like in the previous one, we'll try the midway point. So let's see what is 15 square. And now we know to find 15 square, we will just do it 25 and 1 into 2, 225, right? So now this is 225 and this is smaller than this, which means that the number will be 15 square and then 250 and then 20 square, which means your root has to lie somewhere between 15 and 20. This is 225 and this is 400. So let's try what is 16 square, right? We know 16 square. 16 square is 256. 16 square is 256. So we know 15 square is 225. 16 square is 256 and we need to find 250. So we definitely know it's between 15 and 16. Correct? So the square root will be between 15 and 16 because 16 is now more than this and 15 is less than this. 256. 250 is closer to 256, right? Because if you subtract 256 from if you subtract 250 from 256, you'll get only 6, and over here you'll get 25, right? So the square root of 250 is approximately 16. Okay, this is the approximation. You keep trying to find closest, right? And then you keep drilling down and then you will have something which is the closest, like that. Okay. Now we have the question number 8, which is a pattern. You have to figure out what the pattern is. 1 square plus 2 square plus 2 square is equal to 3 square. Next is 2 square plus 3 square plus 6 square is equal to 7 square. And similarly, this keeps on going. Okay. Now, this is not something that we've actually studied. This is just a pattern that we need to recognize. Okay. So let's look at this. What is happening? You have 1, 2, 2, 3, 2, 3, 6 and 5, 7, 3, 4, 12 and 13. The first thing that we see is that if you multiply 1 and 2, you will get the third number. So 1 into 2 is 2. 2 into 3 is 6. 3 into 4 is 12. Right? The next thing is that from 2 to 3, you're adding 1. Right? So 2 plus 1 is 3. 6 plus 1 is 7. 12 plus 1 is 13. Understood? So the same way, when you have this over here, you have 4 square plus 5 square plus 20 square is equal to what? Now again here, 4 into 5, when you multiply, you get 20. And as per the pattern, this should be 20 plus 1, which is 21 square. Right? And then similarly, 9 square plus 10 square plus what? 9 into 10, which is 90 square. And this is equal to 91 square because 90 plus 1. Okay, this is just a pattern. Now this pattern is already seen, right? You've already looked at this pattern. If you ever have some question which is like this, which has a pattern, it might not be this. So you have to look at the pattern. You have to see what is happening here. Can I add things and see what is happening? Can I multiply two things? Can I see if there's a subtraction over here? And just look at the pattern and then see what the next answer has to be. Okay. And finally, we have the 9th question of this figure it out, and that will be the end of the square number part of the square number section of this chapter. How many tiny squares are there in the following picture? Write the prime factorization of the number of tiny squares. Okay. So we have squares which are these big squares, and in each of them we have these small squares. So we need to tell how many small tiny squares are there. Okay, this is again simple. How many squares are there in this one? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and how many are over here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many total squares are there? This is 9. So either you can count all of them like that, right? Or you already know that if you want to find that, it will be 9 into 9. That will be 81. Correct? So there are 81 big squares. And each big square has how many small squares? This one has 5 into 5, which is 25. Right? So you have 25 squares in one, and you have 81 total squares. So how many squares will be there? Tiny squares. 25 into 81. Right? So you have big squares are 9 into 9. That is 81. Small squares in one big square are 5 into 5, which is 25. And total small squares are 25 into 81, which is 2025. And then you have the question is prime factorization of the tiny squares, which means now you have to do prime factorization of 2025. So you can do it, and then what you will get is this is it. 3 into 3 into 3 into 3 into 5 into 5. So this is the prime factorization, or you can write 3 to the power 4, which means it's 4 times, and 5 to the power 2. Right? That is the prime factorization of this one. That ends the square side of the chapter of the square and the cube, and we will now begin with the cube section. Okay, and if you have any doubts regarding what we've done so far, please write in the comment section so that I can reply and make it clearer. Okay, all right, so now we will move on to cubic numbers, and most of the things that we'll be doing, they'll be in the same same type of stuff that we've done for the square numbers, which is why this section should be much easier to understand, or rather it will be faster to understand. Now, same way, just like we did in squares, a cube, as I've mentioned earlier, is a 3D shape, right? With all sides equal. That's a cube. Now, when you talk about a cube number, you can think of it as the volume of this cube, right? So let's say this cube is a cube with sides 3, right? So all the sides are 3, right? So if I write 3 into 3 into 3, this will be the volume of this cube, correct? And it will be what? This is 27, right? So this is, let's say it is centimeters. So it will be 27 centimeter cube. This is the volume of this cube, right? So in the same way, when I say just a number 3 and I cube it, it basically means that I'm multiplying it by itself 3 times. And the answer 27, this is now a cube number, right? Just like it was a square number when we multiplied it twice. So this is a cube number or a cube simply, right? And when this, which is the cube root, right? 3 is the cube root. And when cube root of a number is a natural number, right? So 3 is a natural number. Then this 27 can also be called a perfect cube. Okay? These are very similar to the terms that we saw in the square numbers. Now, one thing that we can also think about is, like as you saw in the square numbers, if I have let's say -2 square, right, it will still be 4. If I have +2 square, it will also be 4, which means if I take a square root of 4, it can be both plus minus 2, right? This is something we saw. In cubes, it's not going to be like this, right? Because if you do -2 cube, which is -2 into -2 into -2, the answer will be -8. And if it is +2 cube, similarly, it will be equal to +8, right? Which means this whole thing is not going to be there. If it's a -2 cube, like this, the cube root is, it's a negative integer or a negative number, whatever, the cube will also be negative. And if it's positive, it will also be positive, right? This is one difference which is there in square and cubes. So now, once again, if you are asked that you have a cube, what is the volume of it, right? So if you have a cube of side, whatever, cube of side A, right, this is the length, the volume will be A cube, right? And when you want to take the cube root of this, you will make this sign which was there for the square root, and you will write a 3 over here. Okay? So of A cube, this will become A. Right? So again here, in the same way, let's say if I want 27 and I want to find the cube root of this, so I will write it like this and the answer will be 3. Okay? So this is the symbol for cube root. Now, just like we had done for the squares, let's just write down the cubes for the first 20 numbers. Okay? So now, once again, let's look at the units digits, right? We start with 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, right? In the square numbers, all of them were not there, right? All of the digits were not there for the units digit. Over here, again, as you say, we have all of them, which means that a cube root can have any digit as the ending digit, right? Just by looking at the last digit, you can't tell whether it's a cube number or not. Why? Because as I said, as I showed you once again, see, 1 cube ends with 1, 8 cube ends with 2, 7 cube ends with 3, 4 cube with 4, 5 cube with 5, 6 cube with 6, 3 cube with 7, 2 cube with 8, and 9 cube with 9, right? So all of the digits are there, which means the first property is that a perfect cube can end with any digit. All of the digits are possible. They're all acceptable, right? They're all possible. Next, another property that we saw was about the zeros, right? We saw that in a square number, only even number of zeros can be there, right? So it will be either 2 zeros at the end or 4 zeros or 6 zeros, something like that. Now here, what it will be? It will be 3 zeros, right? Because if you have 10 and you want to take the cube of that, you will have 3 zeros, right? If it is 20, it will be 8,000, again 3 zeros, right? So this way, if you want a number to be a perfect cube, the number of zeros will have to be a multiple of 3. Okay? A perfect square ends with 3n zeros. Okay? Where n is a natural number, right? So it will either have 0 zeros or 3 zeros or 6 zeros or 9 zeros and so on, right? So this is the second property. Then you can also, again, just like square numbers, you can take a fraction, right, and find its cube. So what you'll do, you'll multiply 3 into 3 into 3, so that's 27, and you'll multiply 7 into 7 into 7, so that's 343, right? Similarly, you can take, let's say, a decimal, like you can take a number with a decimal and cube that, and you will have, let's say, somewhere around this number, right? So it is still possible, but this is not going to be called a perfect cube, right? For it to be a perfect cube, the cube root needs to be a natural number, which this is not. Okay. The next thing that we saw when we were doing square roots, we looked at odd numbers, right? So let's look at perfect cubes and odd numbers. So what are the cube numbers that we have? We have 1, 8, 27, 64, 125 and so on, right? What are the odd numbers that we have? 1, 3, 5, 7, 9, 11, 13, 15, 17 and so on, right? Now if you notice, if I just take the first odd number, that's the first cube. Then if I take the next 2 odd numbers and I add them, what I get, so next 2, I get 2 cube, right? If I add the next 3, I get 3 cube, which is 27. So 11 plus 9 plus 7 is 27. And similarly, if I take the next 4 and I add them, the answer will be 4 cube. Okay. So what is then, what's the property? That the first odd number or the first one odd number is 1 cube. then the sum of next 2 odd numbers will be 2 cube. The sum of the next 3 odd numbers will be 3 cube, and so on, right? So after this there will be the next 4 will be 4 cube, then the next 5 will be 5 cube, then the next 6 will be 6 cube, the addition of all of these. Okay, this is just a property. It's not a way to actually find the square, the cube or the cube root. This is it's just a property, right? Another thing that we had seen was the differences, right? So if you remember, in square numbers, we saw that the difference was consecutive odd numbers. So let's say again, if I take the squares, we had 1, 4, 9, 16, 25 and so on, right? The difference between these were odd numbers, which then means that if I take another difference, all of them will be 2. Why? Because they're consecutive, right? You have 3 plus 2 is 5, plus 2 is 7 and plus 2 9. So this was for squares. If I do for cubes and do a similar thing, so if I take 1, 8, 27, 64, 125, 216 and so on, here there were 2 layers. And here there are going to be 3 layers. So if I subtract 1 from 8, I'll get 7. Then I'll get 19, 37, 61, 91. I'll do it again. Now I'll get 12, 18, 24, 30. Now once again if I do, now I'll have an equal number in every step. But these are 3 layers. Okay, this is another just a property that you should know. Before we move on to finding the cube roots of numbers, there is one topic which is there in your textbook, which is taxicab numbers. And what are taxicab numbers? This is a number which can be expressed as the sum of 2 different cube numbers. Okay, so it's either called a taxicab number or it's also called Hardy-Ramanujan number. So example of this is 1729, right, which can be written as 1 cube plus 12 cube or 9 cube plus 10 cube. Okay, and if you are given a number and you are specifically told that this is a taxicab number, right, or a Hardy-Ramanujan number, and you have to figure out what 2 separate pairs of cube numbers you can add to get this, you will actually have to list down all of them and then see which one is, possible. So let's say I'll give you an example of one of them. If we want to figure out 4104, I tell you this is a taxicab number, right? Which means it can be expressed as the sum of 2 separate pairs of cubes. So now this is 4104, right? So let's say this can be 1. This is first option and this is the second option, and we have to find these, right? So let's go back to our table. We have 4104. Here if I see 4104, the largest number which is smaller than 4104 is 16 cube, right? 16 cube. 16 cube is 4096. So if 16 cube is 4096, it means that none of these numbers can be bigger than 16. So we have to basically check 1 to 16 and see how it pairs. Okay, so we will have to do it one by one actually. So let's start with the largest one. Let's start with 16 cube. Okay, so we know that 16 cube is 4096. If I take 4104 and I subtract 4096 from it. It will be 8. So here, this number is already a cube, right? This is 2 cube. So we've already found the first number. So this will be 16 cube and this will be 2 cube. Okay, now we'll move to the next, which is 15 cube, right? We'll say 15 cube. That is 3375. Okay, same thing, we will do 4104 minus 3375, which is equal to 729. And this is a very lucky thing that this one, we know also that it is a cube number, right? This is 9 cube. So here in this instance, we have figured this out very quickly. That is 16 cube plus 2 cube and 15 cube plus 9 cube, right? But if you are given another number and you are told that it's a taxi cab number, you have to just keep going in. Like, you figure out what is the largest one, largest possible number, and you use that, find what's the difference between that and this one, and see if that's a cube number. Okay. Now, if we want to find cube root of a number, right? So it's the same way that we had in the, in the square. What are the options? First is that you actually list all of them and see if it falls in the list of the cube numbers, and then you can see what the cube root is. Second is approximation. Okay, the approximation, we will not be doing it, but it's the same thing, right? You have to check, let's say you check 10 cube and 20 cube and then see where it lies between them, and then you approximate. All right. What we'll do here is the prime factorization method. Let's say we take an example of 512. Okay. So we'll do the prime factorization of this. Okay. Now, when we were doing square, we were making pairs and picking one out of the pair, right? Here we'll make 3. Yeah. Okay. So the cube root of 512 will be 2 into 2 into 2. Right? So if your 512 for factors, if you're taking, it's this, right? You'll make bundles of 3, and then from each one you will take 1 digit. So cube root of 512 is 8. Okay, and this is how you're going to do it. Let's say you have the number 2744. So how that will go? Okay, so 2744 is equal to 2 into 2 into 2 into 7 into 7 into 7. You'll again make bundles of 3 and you'll take one of them. So cube root of 2744 is 2 into 7, which is 14. Okay. And that's pretty much it. Okay, that's all that we need to understand in the cubes. Let's just go over the figure it out of the cube section. Okay. So first is find the cube roots of 27,000 and 10,648. 27,000. Okay. If prime factorization is something that you don't understand and it's something that you need me to explain, let me know in the comments, because I believe that you already know this, how to do this. But if you don't know how to do this, just comment and I will create a separate very short video on how to actually do this if this is something that you don't understand. So again, once again, 27,000. The factors are what? 2 into 2 into 2, 3 into 3 into 3, 5 into 5 into 5. We'll make bundles of 3 this time, right? And the cube root will be 2 into 3 into 5, which is equal to 30. Okay. Let's also do the second part, which is 10648. Okay, I think we missed some recording. So, alright, so if you have 1323, this is question number 2. Okay, if you have 1323 and you need to know what you have to multiply this with so that you get a cube number, right? So we did a factorization of this, and what we got is that 1323 is 3 into 3 into 3 into 7 into 7, right? So here this is a group of 3, but this is not a group of 3, right? If I want to make it a group of 3, I have to multiply 1323 into 7, so that then it will be 3 into 3 into 3 and 7 into 7 into 7, right? Which means the cube root of this will then become 3 into 7, right? So the question was, what number will you multiply 1323 with to make it a cube number? The answer will be 7, because after that you can make groups of 3. Now, we have some true and false questions. State true or false and explain your reasoning. The cube of any odd number is even. Let's just look at our list again. Whenever you have an even number, the cube is also even. 2 cube is 8, 4 cube is 64, 8 cube is 512. And whenever you have an odd number, so 1 cube is 1, 3 cube is 27, 5 cube is 125, right? So the parity does not change. The same way parity does not change for square numbers, here also it does not change, right? So the cube of any odd number is even. This will be false. Then there is no perfect cube that ends with 8. This is false. Again, we've already seen that a perfect cube can end with any number. So this is also false. Then the cube of 2-digit number may be a 3-digit number, right? So let's go back to our list. So it's saying that the cube of a 2-digit number may be a 3-digit number. So we start from here. 2-digit number. The smallest 2-digit number is 10. And the cube of that number is 1000, which is 4 digits, right? Now, as you go 10 to 11 to 12, it will only get bigger, right? So the smallest 2-digit number has the cube of a 4. So the cube is 4-digit number, right? Which means that a 2-digit number cannot have a 3-digit cube, right? Because 9 cube is a 3-digit number, but 9 is a single-digit number, right? So the cube of a 2-digit number may be a 3-digit number. That's a false. It has to be at least 4 digits. Okay? Okay. Then the cube of a 2-digit number may have 7 or more digits. Now we have to check whether a 2-digit number can have 7 or more digits. How will we do this? We know that 20 cube is 8000, right? So this is again 4 digits. So if I just want to check whether it can be 7 or more digits, I'll just take 99 and I'll cube it. So if I take 99 cube, right, and I just multiply this, I'll multiply 99 into 99 into 99. This is the largest 3-digit number, okay? Largest 2-digit number. And when you find the answer, it will be 970299, which is 6 digits, right? So, a 2-digit number cannot have a 7-digit cube. As we've just checked the largest 2-digit number and seen that its cube is 6 digits, which means that a 2-digit number cannot have 7 digits. So, this is false. Then, cube numbers have an odd number of factors. Let's just see. If you have a number, let's say 8, okay? The factors will be 2 into 2 into 2. Okay, so there are 3 and that's odd. That's true, right? But if I take another number, let's say 10648, which we've seen previously, this is 2 into 2 into 2 into 11 into 11 into 11, which means now there are, so this one had 3 factors, this one has 6 factors, right? 1, 2, 3, 4, 5, 6. That's even. So, cube numbers have an odd number of factors. That's false, right? It will have a multiple of 3, but it doesn't have to be odd or even. It can be either, right? Next is, you are told that 1331 is a perfect cube. Can you guess without factorization what is its cube root? Now, if it is a perfect cube, the same way we did for square, right? We will do the same type of thing over here. So, we have 1331, right? We know that 10 cube is 1000, and we then know that 20 cube is 8000, right? Which means this has to lie somewhere in the middle, right? If it ends with 1, it means that the cube root also ends in 1, because 1 cube is 1, right? So if it has to be between 10 and 20 and it has to end with 1, which means it's 11, right? This is because it is 1331. Let's try again. The next one is 4913. So 4913, if we know that it is a perfect cube, right? So once again, we know that 10 cube is this and 20 cube is this, which means this also falls somewhere between these two. We know that the cube of 7 ends with 3, right? We know that 7 cube is 343, right? Which means that here also, this also should end in 7. And since it's between 7 and 10 and 20, this will be 17, right? This is because we know that it's between 10 and 20, and we know that this is a perfect cube, right? Similarly, if we have 12167, that's the next question. 12167. So now once again, now this is more than this, right? So let's see, we know that 20 cube is 8000. 30 cube will be what? 3 cube is 27, and then 3 zeros for the 0, right? So 30 cube is 27,000, which is now it's more than this, which means the cube root of this will have to lie somewhere between 20 and 30. Okay, because 20 cube is less than this number, 30 cube is more. And this ends in 7, right? We know that 3 cube ends in 7, which means that if this is a perfect cube, it has to end in 7 and it is between 20 and 30, which means the cube root is 23, right? So 23 cube will be 12167. Okay. Then the last one is 32768. Same thing we will do again. We know that 130 cube is 27000. Let's check what is 40 cube. 4 cube is 64. And for 0 you'll have 3 zeros, right? So now again this comes here, somewhere here, right? Because 27 is smaller than this and 64,000 is bigger than this. This ends in 8. What ends in 8? 2 cube ends in 8, right? Which means the cube root of this will also end in 2. And it's between 30 and 40, which means it has to be 32. This is the same thing, same way that we had done the square number exercises. Okay, so which is why I'm not explaining it in detail. Still, let me know if this is, if you want to understand more than this. Then we have the last one, which is which of the following is the greatest, and explain your reasoning. Now you can obviously, solve all of them and then find what is the largest one. But let's say we know that if you have 2 cubes, let's say I have, let's just try something. Let's say 2 cube and 3 cube and 2 square and 3 square. We have these 4 numbers. Okay, let's just try it. Okay. Now 2 cube and 3 cube. So 3 cube is 27. 2 cube is 8. 3 square is 9. 2 square is 4. Right? When I subtract them, this becomes 19 and this becomes 5. Right? Which means that if the numbers are the same, the difference of the cube is more. Right? And if I go one step niche, let's take one square, 1 cube and 2 cube. Right? So 2 cube is 8, 1 cube is 1, and this difference between both of them becomes 7. And this is also smaller than this, right? So basically what I'm trying to say is that if the 2 numbers are the same, the difference between the cube will be much more than the difference between the squares of those numbers. And if the 2 numbers are greater, then their difference will be more than the numbers that are smaller. So here you have 67 and 66. So 67 cube, 66 cube, 43 cube, 42 cube, 67 cube, 66 cube, 43 cube and 42 cube. Right? So the first thing we are saying that 67 cube minus 66 cube and 67 cube square, 67 square and 66 square. So when the numbers are the same, right, the greatest of those two will be this one, 67 and this, out of these two. Okay. And similarly, between these two also, if it is 67 and this is 43, this will still be greater because these numbers are smaller, so the difference will be smaller, right? So the greatest difference will be this one, 67 cube and 66 cube. And the smallest difference will actually be this one. Why? because the numbers are also smaller and they're also squares, right? These two, if you want to see, you would actually have to calculate which one is bigger and which one is smaller. But the greatest and the smallest, the cube and the larger number, and the smallest will be the square and the smaller numbers. Okay, so which is the greatest? It is this one, right? So as the numbers increase in size, the difference between the cubes is higher than the difference between them in the squares. That's the main reasoning. Okay, and that finishes this chapter. Yeah, let me know if you have any doubts, if you have any questions, or if you want me to explain anything else once again. And thank you for joining in. I'll meet you in the next chapter, in the next video. All right, take care. Bye.